Welcome, everybody. Thank you so much for coming here today. I'm really honored to be up here to talk to you about this project that I'm super passionate about. So, if you are not here and you're watching on YouTube later, you might have been at the after party. I hope you really enjoy this too when you're all rested up. So, let's get started. I am extremely happy to see that we've all kind of gotten behind modules as the dependency solution for us in the Go community. Now that we have this part of the problem solved, this part of the dependency story solved for Go, we can move on to other problems. And we still have problems that we need to solve in the Go community with respect to dependencies. So there's still work to do. Let's go back to the beginning, though. Let's go back to basically just how do dependencies work in Go? We need to set the stage for this problem. So as we know, dependencies do and have always started with version control in Go. So we've got our code in GitHub and GitLab and so on. We basically just have go get, and when you do a go get and you point it to a GitHub repository or wherever it might be, go get will just simply do a git clone. Pull the code directly down from version control. And this is so simple, and it works so beautifully. That's the power of it, is the simplicity. But we've been risking disaster for a little bit now. As our community scales up and scales up and scales up, issues crop up where maybe code will disappear for some reason, or code will be inaccessible for some reason. And entropy grows as the community grows because the more and more packages we have, obviously Murphy's Law takes effect here, and the more and more chance that the package will not be available to someone who depends on it. And that's when apps start breaking, and the risk of apps breaking goes up as well. So let's look at a couple of ways that apps have broken in the past. You might be familiar with some of these. You might experience some of these. So if you're a module author, you can accidentally just delete a tag. Maybe you're only deleting a tag for just a second so that you can update the code on that tag. Well, with modules, everyone who depends on that tag is going to break because the code will be different. Or if the tag doesn't exist, your build will break because the code is not there. Well, of course, you can delete a repository too. You might not realize that anyone is depending on your code. But if you're just done with the code, it makes sense to delete the repository. So if you do that, obviously everyone who relies on your code is going to break as well. We've seen this one actually fairly recently. GitHub makes it very easy to rename or even change the casing of a repository. I see a couple smiles. I think people maybe remember this one. It's so easy to do that. You just go in, maybe you put in your password, and then it's renamed. Well, if you do that rename, builds will break. We've seen this. It's happened a couple times now. And then there's things that you, the package author, have no control over. Now, I know just about everyone in this room has experienced a GitHub outage. If you're a package or a module author, this is not your fault. But if there is a GitHub outage, folks cannot pull down your code. So we're going to talk today about one part of the solution to all those problems. That's the Athens project. So I work at Microsoft. I'm on the team that's rewriting Windows 95 in Go. We also do the Athens project. So look for that coming out soon. But this is going to solve this problem, but it's also going to solve an even more problem that we're going to kind of unfold throughout the talk. So first part of the solution. We've heard of the module download API. We've heard of module proxies and mirrors and so forth at this very conference. We've also read about them in the past in the module documentation and so forth. The module download API is the core, the kernel of the solution that we're going to build on top of. It's a relatively small part of the module spec, but it has a massive impact. So let's go through it really quickly. We've got two sort of metadata endpoints. These are REST API endpoints that are just simple HTTP GET. So they give you the list of versions of a module and the latest version of a module. We've got metadata endpoints that give you the .mod, the go.mod, and the info metadata endpoints for a specific module frozen at a specific version, preferably a semver. And then we've got the most important one. This is the one that downloads source code. You can download a zip file of a module frozen at a specific version. And that is a zip file. I'll repeat that. This is not a source tree. This isn't a Git clone. This is a zip file. And that's source code that is frozen. It's immutable at that version 1.0.0. But the most important part about this API is that it is ours. This is the first time that we have a purpose-built API for Go dependencies. And it's not shared with the Git protocol, and it's not shared with any other API, like not shared with the GitHub API or anything else like that. It's our API, and it's owned by the Go community because it's open and anybody can implement it. So what can we do with that? Well, of course, we're going to build an API server. This API server can be sort of an abstraction layer in between the version control systems and us, the people who depend on packages. And as we all know, one layer of indirection is the solution to every problem in software. And what's really cool is that we already have hosted versions of these API servers. We heard about one, proxy.golang.org, the one that the Go team hosts. There's also one called gocenter.io, and I suspect there's going to be more and more as time grows. So in almost all of the implementations so far, and I hope most of the implementations going forward, these API servers simply talk to version control. And then you just point go-get at the API server, and go-get talks to the API server via this download protocol. This is the REST API. This is not git clone. So with this abstraction now, we can separate these two concepts. One concept is code and development. This is the code that you have in GitHub that you're merging pull requests and closing issues, and maybe even doing some naughty things like force pushing commits and deleting tags. That's all okay, because we also have this thing called a dependency asset. The dependency asset is essentially that zip file. That's the immutable snapshot of code, not the Git tree. The immutable snapshot of code at a specific version that is optimized to give folks for downloads to store on their computer as dependencies so they can build their app. And this is what we get from making this separation. With code and development, we've seen entropy. We saw that slide where I went down 4 or 5 different reasons that things can break. And this entropy grows as our community grows. But once we switch over to dependency assets, we get stabler builds because these are immutable and they're optimized for folks to download onto their machines and run and build as dependencies. But there could be the potential for some conflict here. If you're a module maintainer, you no longer have your code in a repository being served up directly to folks who depend on that code. There's now something like a registry or an API server that is the middle person, the thing that sits in the middle between you, the maintainer, and the folks who are depending on your code. Now, we've seen registries in other languages before. We've seen the pros and cons of registries. The pros are that they're available, they're very highly discoverable, and everyone can use them. And we have that, and it's really amazing. If you haven't used proxy.golang.org, check it out. It's really easy to use. It's built right into the Go tool. It's awesome. And in Go 1.13, it's going to get even awesomer. But there's prior art that serves as a warning for us. If folks are familiar with the Node package management in the JavaScript ecosystem, there's been issues with that, breaking. It's a single point of failure. In the NPM world, NPM didn't even have an outage. They were just kind of forced, legally obliged to take down a package that it just so happened that everyone in the JavaScript ecosystem depended on. So the world blew up in the JS ecosystem. We can learn from this history and we can improve. We can avoid these problems. So that's where Athens starts to solve the problem, okay? So Athens is an API server. It has one-to-one parity with any of the other API servers out there. But it doesn't really replace proxy.golang.org or gocenter.io. But it does still sit in the middle of version control systems. Now, it also can talk up to those public registries, those public proxies. So we see JFrog's gocenter.io, and the Gopher is proxy.golang.org. And it still talks to all of those, and it pulls code down from all of those. and you still point go get at Athens. But the thing that makes Athens one of the most important implementations is that Athens will store code in storage that you control. It's not abstracted away from you anymore. The fact that you store code, that Athens stores code in storage that you control, means that there's no more layer of abstraction. There's no one else controlling the dependencies that you rely on, and there's no one else serving up the dependencies that you rely on. You control it. So we're going to see that. We're going to see me tempting the demo gods, running Athens on my local machine, and pulling code down from the internet. So cross your fingers. Let's see how this works. So I have a public repo. This is going to be posted. It's public right now if anyone wants to go check it out. And I am going to run Athens in Docker. Now, the Athens documentation has quite a few different ways to run it. Docker is the most expedient for me to do in front of all you quickly. So I'm going to do just that. So I'm going to start up Athens. We've got it running on port 3000. And there are a few other steps. I'm going to point my Go toolchain to talk to the Athens local proxy. I am going to purge my local modules cache, make sure that we're forcing my build to go talk to Athens to pull down dependencies. And then I'm going to run my little app. So now we can see we're starting to pull down dependencies. But from where? Well, this is Athens starting to serve up all that metadata. This is Athens looking in its own database and seeing that it doesn't have information about any of these modules. Athens doesn't have a cache, but this would be similar to a cache miss. This is stable storage. Once Athens has a miss, it says, okay, well, I need to download this code from upstreams. It's configured in this case to be downloading code from version control. So you can see it downloaded a bunch of info and mod files, and then it started to download zip files. And those are those source artifacts. So you can see here, that kind of matches up with a bunch of finding output and then downloading and extracting. And now we've got my server running. So I was inspired by Katie Hockman's talk. She talked a lot about dogs. I'm torn between dogs and cats, so I wrote a server that serves up pictures of both. So can I get a hand for the cat folks in here? Ooh, that's pretty weak. How about the dog folks in here? Okay, well, the good news is we're going to do this build twice. So we'll start with the dog photos and move over to the cat photos. So a couple dog photos powered by Athens. All open source, by the way, if you want to add your own dog photos. We're going to close this down. And now we're going to do the unthinkable. We're going to shut us off from the internet. So that's Wi-Fi. Here's Ethernet. So we're air-gapped. We've got no access to the internet. We also are going to purge our local cache. This is the big dramatic moment of my demo. Get ready. Okay, so no dependencies locally on my cache, nothing in my Go path. We're in modules mode, and we've got to download dependencies from the internet, from somewhere. Obviously, we're not going to get them from the internet. So the spoiler is, of course, we're going to get these modules from Athens because Athens has them in storage. But I want you to notice what happens when I do this run. It happens a lot quicker. And the reason for that is it's in my storage now. This is a storage that I have chosen for Athens, and it happens to be very close to me because it's running in a database on my machine. Okay, so we've got our server up again. We saw dogs before. Let's see some cats powered by Athens. That's the cat that I want in my house. Okay? So that last part, I want you to remember that part. It's not just dramatic for the demo. It's actually really important that we can have Athens running while we're offline. But on the other hand, that's kind of just a dramatic moment for a demo. Why would you actually run your own Athens in an organization? Well, we've seen use cases for Athens. We've seen folks running Athens primarily for the privacy aspect. And it's not just, I don't want to give my information away. It's that you can configure Athens to access your private repos and serve up modules for your private code. Also, Everyone on your team can point their tool chain to your Athens, your organization's Athens, similarly to what I did on my machine. And you can filter all of your go build and go get and go run and go install requests through Athens and avoid leaking that information about your private modules up to a central hosted registry. Next, since everyone's pointing their tool chains to Athens, that means Athens has every dependency that your apps rely on, so you can start auditing them for license issues and security issues and so forth. That's really great for an enterprise. If we want to take it to the next level, you can firewall all of your whole team, your whole organization off from the internet if you're something like a highly regulated firm. That's what isolation means here. Everybody can point to Athens. Even Athens can have no access to the internet like you saw here. And Athens can store absolutely everything that your app needs to build, every single dependency that your app needs. But there's a much more important reason that folks run their own. And there's a much more important reason that I believe we should be trying to run more of these things, more of these Athens servers, or more of other API server implementations. And that is decentralization. So in the Go dependencies ecosystem, ever since V1 of GoGet, ever since the day that GoGet was introduced to the Gopher world, folks have been able to write code on their machine, do a git push, and own the code in GitHub that's immediately available for any other Gopher to depend on. It was in everyone's individual repositories. That's the decentralization that I refer to here. Everyone owning the source code and controlling where it's served from and controlling its fate. Now that we have this sort of abstraction, now that we have this layer of indirection, we risk losing decentralization. And if we don't do some work as a community, we're going to only have hosted servers, but not decentralization. So we're going to have all the pros of hosted servers, which are very familiar and near and dear, but we're going to also have some of the cons, and we're not going to be able to mitigate against them. So we need to do some work. But if there's the one most important thing that we do need to do, we need to keep in mind right now, is to remember that API. Remember how I said this is our API? Well, it's an open API. It's actually fairly simple to implement. But if we don't actually use that API, if we don't actually cast our votes to keep that API open by running instances of the API and implementing the API, well, it may as well be closed. Doesn't really matter if there's only one implementation of the API. It may as well be closed if there's no one else running the API. So, today, I'm putting out a call. Go try Athens. Go run Athens. Go build your own implementation of a module API server and run that. Go get involved with the Athens community. Or go make your own community. And make your stuff work with the rest of the ecosystem. Make your stuff work with the modules API. And every single person in this room, every single person watching on YouTube, every single person reading on the live stream, everybody who does that will be casting their vote to keep this API vibrant, keep it open, keep modules decentralized. And with that decentralization means that we're going to get those benefits of dependable builds. We're going to get those benefits of keeping our ecosystem healthy as it has always been. We're going to keep those benefits of helping our ecosystem grow at this amazing rate that it's been growing. And we're going to keep those privacy benefits that I talked about as well. So, if you're interested in running Athens, which I dearly hope you are, and even better if you're interested in coming to contribute to Athens, well, we have a motto in our community, in the community of Athenians. It is that absolutely everybody is welcome. And we even have a cute gopher to welcome you. And I mean that. We all mean that. Regardless of your background, number of years you've been writing Go, number of days you've been writing Go, if you've never written Go and you're just interested in coming to get started, if you want to learn something, if you don't know anything about servers, it literally doesn't matter. We make absolutely every effort we can to welcome you into the community, get you started with what you want to get done, And sometimes we might push you a little further towards submitting that first pull request, but we're nice about it. So if you are interested in getting involved, here's some real things you can do. On docs.gomods.io, we've got instructions for what you can do to get started. There are a variety of different ways to do it. We've got extensive documentation on how you can run an Athens quickly. You saw me do it with Docker with a command. You don't even need Docker. You can just download a binary, a Go binary, and just run that yourself as well. We've got instructions on how to run it in the cloud as well. There's plenty of stuff on there. And of course, contributions there are welcome too on the docs. Or, it's actually even easier than that. You can come into the Athens channel on Gophers Slack. You can ask if you've got problems running Athens. You can come just say hi. You can ask a question. You can get help submitting that first pull request. We make absolutely every effort we can to welcome people to our community. And I really hope you come join us. Test out that assertion that I've just made. So I want to say thank you again. And I want to say on behalf of every single person in the Athens community, thank you so much for letting me stand up in front of you and talk to you about Athens. And we really hope we see you soon. Thank you, everybody. Have a great Friday.